హలో హలో
సార్ ఎస్ సార్.
అమ్మ రీస్టార్ట్ అయిందమ్మా, ఒక్క నిమిషము. ఓకే, సార్ క్లాస్ నడుస్తుంది. హలో హలో
ఎస్ సార్.
అమ్మ ఒక్కసారి ఇది స్లైడ్స్ కనపడుతున్నాయేమో చూడండి అమ్మ ఒకసారి. అమ్మా ఇది పీడిఎఫ్ కనపడుతుందమ్మా? కెన్ యూ సీ దిస్ పీడిఎఫ్?
Yes, sir.
ఓకే, సో వెరీ గుడ్ మార్నింగ్ మా. Like 25 to 35, can you respond today? Hello? Hello?
Yes, sir.
25 to 35, like some of
Yes,
you please
sir.
respond so that I will understand the reachability. Is it okay?
Yes, sir.
Yeah, ma. Today what we do is, let us see what we have done yesterday. Yesterday, first we have taken a bike riding case, and subsequently we have seen what is its structural representation. And from that structural representation, we have seen how to use the free body diagram to represent that particular system mathematically. Yesterday, what we have seen is the mathematical representation of a automobile system, like a vehicle, a two-wheeler. And the procedure is initially you started with the simplification from real system, physical system to its equivalent structure. Then you made some simplifications. From that you identified what are the masses. Then you have drawn some free body diagram. And from the free body diagram, we have taken a mathematical equation using D'Alembert principle. Today we will see one more example so that you will have clarity what we are doing when we say mathematical representation of the mechanical system. 1 minute, I think still some more people are joining. Yeah. Can you see a car here, ma? Can you see a car? Are you able to see this slide?
Yes, sir.
Another
Yes, sir.
example, a cruise control of a car. That means I want to control the speed of a car, let us say. So here I have a car, and as a part of this control system, observation of this system, my interest is in evaluating the velocity. My interest is in evaluating the velocity. Now, when we say mathematical modeling of the system, let us recapitulate what are all the steps that we adopted. First, we will be defining the objective. What is the objective here? I want to measure the velocity of the car. I want to have an equation for velocity of the car when some acceleration force F is applied. Let us see that in this particular diagram. Here, F is a force that is generated from the engine, and subsequently it is causing some kind of motion. So let us say probably at home or something, you take it as a reference and it is moving. Now car is at some position. I am taking that as a displacement. In this like a diagram, what we have is a physical system called car, where the forces, that input is force here and output is a displacement, or even I am interested in measuring the velocity. Now let us evaluate, or let us write the mathematical equation for this particular mechanical system using this free body diagram. So what are all the steps that we have to do is, first, this is the original system. First, let us have a structure for this. When you see a structure, it looks something like this. Are you seeing this diagram where we are having modeling of cruise control? Please respond, ma. Are you seeing this? Are you seeing here some reference, some mass and B for friction? Are you seeing here?
Yes, sir.
Yeah, let me explain this, how we got this diagram. In this diagram, if you see the left side, this is the reference mark. That means this car is having some displacement. So this is the reference position 0. It got some displacement X. Next thing, let me explain M here. What is M? If you observe the car here, it is moving along a line. And subsequently, we will be defining a variant of the motion of the mechanical system that is called as a translational motion. For translational motion, when you apply some force, because of the mass of that particular object, obviously it will resist. So that is the place where we are going to have, first we are identifying the elements in this particular, what you say, moving of the car, this particular cruise. Then what is the first, what are all the three elements we are having in a mechanical system? In translation motion, mass, spring and damping. Now here I am assuming that the friction between the tires and this particular road, if you see here, what I have taken is this B. B is for what? Damping. I am assuming that but this damping refers to a variant of frictional force. And subsequently, I am assuming that the spring action, the spring action between the wheels and this particular road is negligible. I am not considering spring action here. Yesterday, if you remember, if you recollect, there we have taken that suspension system where we consider the spring action. That means here I am considering only two major elements. The first element is mass, which is opposing this particular movement. And what the second element is, between this particular car and road, there will be some friction. You see, whenever you are riding on a bike with like some huge air will be blowing against your flow, this face, right? That will be the friction because of the air. So that friction, as well as friction given by this road, you
Yes,
take
sir.
into, hello? This mass and the friction on the road or this air you consider, and let me represent here. This is my car mass equivalent. That's why it is represented with M. And subsequently, it is connected with this particular, it is having some resistance, opposing force. So B is drawn. Now force is applied, how, in what direction force is applied? In this direction. Now let us recollect the sequence of steps. If you recollect earlier our discussion, first we have to identify what is the scope or purpose, what is the purpose of the model. Here I want to have an expression for velocity of the car, and subsequently my step is I need to construct a model which will be giving the velocity of the car, which I can use for controlling. Next, define the boundaries. When I say boundaries, what is your interest in that particular physical system? Here the physical system is the mechanical system. So here, what is your interest? I want to control the speed of the car, and there is some road. This is what the boundaries. Road forms the part of the environment. This is what the boundaries. If you are considering, if you are expanding boundaries, what is going to happen is more and more forces, and in turn more and more elements are going to be added to that particular system, and in turn the system may become complex. So it is up to you to what extent you want to understand the system or you study the system. Based on that, the boundaries are going to be defined. The next point is postulate the structure. What is the postulation of the structure? If you see this diagram, I am saying that I have mass, this M of the car, which opposes the force generated by engine, and that is mass. And subsequently, the friction between the car, the tires and roads, or the car and the external environment, that is shown as B. This is again will be with respect to this particular, these are all opposing forces. This B, that is friction and mass, they will be providing some force in opposite direction to this particular applied force. Now I should have a reference, right? This particular friction will be between car and ground. That's why these elements are drawn here. The next element of your interest is, what is the result of this force? Probably it will be having displacement or it will be having velocity. And subsequently in this cruise control system, I need to have a measure. Here this particular displacement is the output of this particular system. For that I need to have some reference position. This is my 0, and this body wherever it is X. Is it clear? If you want, I can repeat. Let me know this part is clear. Let me repeat. When you say postulate the structure from the physical system, that is your car here, you want to have a mathematical model, and subsequently you define the purpose, boundaries, and now you have a schematic diagram. That postulate structure I can consider in terms of schematic diagram, and in turn now I got this. Now you select variables of interest. What are the variables of your interest? You are applying some force and you want to see the velocity or some kind of what you say displacement. So here the variables of interest are X, V and F. As you are applying F, probably the velocity or displacement is your concern. That's why like F is not described, only X and V are shown here. Now let us move to the next step. Now here, what are the elements? I have mass, I have this particular friction, and subsequently let us think in terms of free body diagram. When I say free body diagram, what you are going to have, you will be considering mass, and subsequently you will be writing 1 minute ma. Can you see this whiteboard ma? Hello, can you see the whiteboard?
Yes, sir.
Okay. Now, excuse me. Let us say this is my mass. I am representing here. This is my mass. Are you seeing this like this box inside M? Can you see this? Can you see this, ma?
Yes, sir.
Okay. Now some force is applied, right? So when you say some force is applied, what you do is, see, force you are applying in this direction. Let us say this is my force and your force will be in this direction F. Can you see F here? Is it okay? Now it is something like you are trying to pull this car and subsequently it is going to create some opposition force. That force will be in this direction, ma. That force will be this way. 1 minute. So that force will be in this, opposing force will be in this direction. What is this opposing force? This opposing force is because of this mass. That particular opposing force can be derived from Newton's second law. What is Newton's second law? F equal to ma. That is mass multiplied by acceleration. But what is acceleration? rate of change in velocity or rate of change of displacement. So here I can have the expression here d square x by dt square, and its direction is in this particular direction. Next thing, next element is, we said that there is some friction here. At this place we have some friction, and this friction, or in this side, that friction also opposes the force whatever you are applying. So that friction, what is that friction? That is represented with your damping factor B. Now here the displacement is x. Here you are having the displacement x, and some kind of opposition that is given by the mass, that is given by d square x by dt square, and it is providing some friction. When you say the frictional force is proportional to the velocity. When you say proportional to the velocity, if you recollect for this frictional force for damper, it is F equal to B into dx by dt. Let me repeat. I am applying a force F on this particular car. Car has a mass. It has friction. So you are having an opposition force of m into d square x by dt square because of the mass, and because of the friction, you are having an opposition force given by B into dx by dt. So this is what. Now let us come back to our earlier discussion. So if you see here, from here we moved, here I have mass and here I have friction, and subsequently if you write the equations, if you see here, the first force is acceleration, that is given by m into d square x by dt square. And the second one is frictional force, that is given by B into dx by dt. 1 minute, ma. So if you see the total force, these two forces are the opposing forces, and the force applied is F. That is, I can write F equal to FA. Here FA refers to the opposition force because of the mass, and the second one is FF refers to the frictional force. So F equal to FA plus FF. In turn, I can write F equal to m into d square x by dt square plus B into dx by dt. This will be the mathematical representation of my system in terms of displacement. But let us say my variable of interest is velocity. As we have given here, if you see here, we are interested in velocity. So let us translate the parameter x into velocity. So what is the relationship between velocity and the displacement? V equal to dx by dt, and a equal to d square x by dt square. Then I can write it as v dot plus, v dot means what? dv by dt plus b by, here this m is taken to the left side, b by m into v equal to f by m. This is the mathematical model. I'm stopping here. If you have any doubts, you can ask me now. Let us see the procedure once. Define the purpose. I need velocity. Define the boundary, means what is your interest, what is the scope. Next one, from that, whatever the environment you have defined, whatever the boundaries you define a structure. This structure gives the schematic, this one. Now, through this structure, you will be identifying the variables. Here, x, v, and f kind of thing are the variables. From that, the next step is you write down the forces which will be mapped onto free body diagram. Then you apply D'Alembert principle. One variant of D'Alembert principle is the forces acting on a particular body will be equal to forces opposing on the body, or when a particular body is in equilibrium, the algebraic sum of the forces will be 0. That is giving F equal to FA plus FF. If you don't understand that, let us say here F is the force I am applying, which is going in the right side direction. And this force, because of the mass, that will be left side. And even friction also will be in this direction. Here friction, I am considering that atmospheric friction. So if you sum up that forces, F is right side and frictional force is left side, and the force because of the mass is left side. So it will be taking opposite direction. So I can write F minus F because of M minus F because of B. Here it is represented as, instead of M, it is represented as because of the acceleration, F minus FF, that is friction, minus FA equal to 0. This is what a simplified, like this is what the mathematical representation of a simple system. I am passing here. If you have any doubts, you ask me, ma. The process is clear. Hello. The steps are clear. (404) Ajay. Ajay, unmute ma.
Yes, sir.
Yeah, steps are clear.
Okay, sir. Clear.
Sai Teja.
Yes, sir.
Like, is it okay?
Yes, sir.
Yeah, Sivajyoti.
Sir,
Any doubts here, ma?
no, sir.
Okay, let us go back to the yesterday's problem once again, so that we will establish more confidence. Okay.
Sir.
1 minute, ma. Can you see this slide, ma? Mathematical modeling of mechanical systems. Are you seeing this? Are you seeing the PPT? Hello? Okay, thank you.
Sir, in previous problem, once explained, apply relevant physical laws, sir.
So let me take this particular problem. Can you see this, ma? Can you see this diagram? This is the structure of your mechanical system. This could be the corresponding elements will be a part of some mechanical system. It could be an automobile, it could be in a factory, or it could be in a robot. Are you able to see the diagram here? Yeah. What elements we got here is, this is the reference, probably something is hanging, and subsequently here I have two masses where the first mass and the reference is like separate by means of spring action and damper. That means probably the mass has to be slowly, like it has to be like elongated for a long time, and that is provided with some stiffness. Then if you observe here, on mass M1, force F of t is applied, whereas there is no mass on M2. Because of this force F of t, there is some displacement on M1, that is nothing but Y1. And on this, there is some displacement, that is M2, some displacement, that is nothing but Y2. ఇంతకుముందు ఎగ్జాంపుల్ మనం x అని తీసుకున్నాం కదమ్మా డిస్ప్లేస్మెంట్, దాని బదులు ఇక్కడ ఏమనుకుంటున్నామంటే y1 అంటున్నాం. ఈ y1 అంటే మీనింగ్ ఏంటంటే ఇది 0 పొజిషన్ అనుకోండి. Let me mark here. Let us say this is my 0 position. From here to here it is y1. Okay. From here to here it is y2. That is what the meaning, the displacement. Okay. Now that means this object has moved something. That's what this y1 and y2 are referred to. Here you need not take exactly this as a reference. From initial position it is moving some displacement. It is something like this. Now, so if I want to have a transfer function, first I need to have a mathematical model for this. When I say mathematical model, first you identify masses, or you identify the places where you will have displacement, where you are having displacement m1 and m2, and subsequently you have to write your free body diagram for mass m1 and mass m2. What forces are acting on m1? You are pulling this down, that is f of t, whereas because of the spring and all, it is pulling up, so that direction will be opposite to f of t. Similarly, as it is hanging down, because this is pulling, this mass also will be causing its force to be upward direction. మీరే ఒక మనిషిని తోశారనుకోండి, ఆయన అలాగే నిలబడడానికి ట్రై చేస్తాడు, సో he will be resisting that force. So the force because of the mass also will be in opposite direction to f of t. Now let us see that in the next slide. If you see here, f of t is away from this particular body, whereas if you see fb, what is fb, ma'am? Because of this damping, it is opposite direction to ft. Similarly, what is fk1? A spring is between the reference and mass, that also will be in opposite direction to ft. Now when you pull this mass will be opposing, so its direction is also opposite. So this also here fm1 అనేది కింద పెట్టినారు కానీ, even you can take here and it will be inside. Coming to this, there is a spring between m1 and m2, some effect will be there, that effect is shown here. Now let us have the equation. fm1 అంటే mass వల్ల d square y1 by dt square. ఇక్కడ fb అంటే ఏంటి? డాంపింగ్ అనేది వెలాసిటీకి డిపెండ్ అయి ఉంటుంది. సో fb ఈక్వల్ b ఇంటూ dy by dt. స్ప్రింగ్ కాన్స్టెంట్, స్ప్రింగ్ ఎఫెక్ట్ ఎలా ఉంటుంది? డిస్ప్లేస్మెంట్ కి. That's why fk1 equal to k1 into y1, whereas the last component is the force because of the spring. What is happening? The spring, normally this mass will be pulling down. మీకు ఒక రెండు మాస్ మధ్యలో ఒక స్ప్రింగ్ పెట్టారు, మా కింద లాగుతుంటే స్ప్రింగ్ ఏం చేయాలి? పైకి పుల్ చేయాలి. అందుకని దాని డైరెక్షన్ fk2 ఫోర్స్ అనేది అప్వర్డ్ డైరెక్షన్ ఉంటుంది. నౌ ఇట్స్ వాల్యూ విల్ బి k into displacement. The displacement is y2 minus y1. Is it okay? Is it okay? Here, this is the free body diagram for mass m1, and subsequently I have taken what are all the forces that are acting on that particular body. f of t, దీన్ని ఏం చేస్తున్నాము? కిందకి పుల్ చేస్తున్నారు, బయటికి అంటే ముందుకు లాగుతుంది అనమాట, అందుకని అవుట్వర్డ్స్. బట్ ఇది ఏం చేస్తుంది? పైకి లాగుతుంది, డాంపర్. అలాగే విచ్ విల్ బి డిపెండింగ్ ఆన్ వెలాసిటీ. స్ప్రింగ్ ఏం చేస్తుంది? డిస్ప్లేస్మెంట్ కి ప్రపోర్షనల్ గా ఉండి పైకి లాగుతుంది. మాస్ ఏం చేస్తుంది? యాక్సలరేషన్ తో డిపెండ్ అయ్యి పైకి లాగుతుంది. దట్స్ వై ఆల్ దీస్ ఆర్ ఆల్ ఇన్ ఆపోజిట్ డైరెక్షన్ టు f of t. ఇక్కడ మాస్ m2 ఏంటంటే, ఇట్ ఈస్ ఆల్సో హ్యావింగ్ సమ్ ఎఫెక్ట్ on m1. What kind of effect? In between some spring action is there. Because of the spring, మీరు నార్మల్ గా m2 ఏం చేస్తుంది? సంథింగ్ లైక్ ఒక ఆబ్జెక్ట్ కింద ఇంకో ఆబ్జెక్ట్ కింద ఆబ్జెక్ట్ ఏం చేస్తుంది? m2 కిందకి పుల్ చేయడానికి ట్రై చేస్తుంది. దెన్ the spring will be providing a force which is in opposite direction to f of t. అందుకని మీకు fk2 అనేది ఆపోజిట్ డైరెక్షన్ లో ఉంది. బట్ ఆ ఫోర్స్ అనేది దేని మీద? ఇక్కడ చూడండి ఒక డిఫరెన్స్, ప్లీజ్ అబ్జర్వ్ దిస్ డిఫరెన్స్. In this spring, one end is rigidly fixed. In this side, this spring is not rigidly fixed. దీని మీనింగ్ ఏంటంటే, see this diagram once more. If you go for our 1 minute. Not this. ఇక్కడ చూడండి అమ్మ, ఐఎమ్ టాకింగ్ అబౌట్ స్ప్రింగ్ ఇన్ అవర్ డయాగ్రామ్. ఇక్కడ స్ప్రింగ్ చూస్తే మీకు ఏముందంటే, ఒక సైడ్ రిజిడ్ గా ఉంది, ఓన్లీ ఒక సైడే మూవ్ అవుతుంది. అంటే ఏంటి? స్ప్రింగ్ ని ఒక చోట ఒక రాడ్ కట్టేసి జస్ట్ యూ స్టార్టెడ్ ప్రెస్సింగ్. మీరు ఎప్పుడైతే వదులుతారో అప్పుడు ఫోర్స్ ఏమవుతుంది? అపోజింగ్ ఫోర్స్ ఏమవుతుంది? ఓన్లీ రైట్ సైడ్, లెఫ్ట్ సైడ్ కనుక టైట్ చేస్తే ఓన్లీ రైట్ సైడ్ కి మూవ్ అవుతుంది. హియర్ దిస్ ఫోర్స్ విల్ బి డిపెండింగ్ ఆన్ ఓన్లీ దిస్ పారామీటర్.
స్లైడింగ్ అనిపించట్లేదు సార్.
స్లైడ్ కనపట్లేదా? 1 minute మా.
నో సార్.
1 minute. Ma. అమ్మ ఇప్పుడు కనపడుతుందా స్ప్రింగ్?
Yes, sir.
ఓకే, ఈ కేసులో తీసుకోండి, స్ప్రింగ్ లెఫ్ట్ సైడ్ టైట్ గా కట్టుంది కదమ్మా. ఆర్ యు అజ్యూమ్ దట్ దిస్ ఈజ్ యువర్ జీరో, ఇట్ ఈస్ నాట్ మూవింగ్ ఆన్ లెఫ్ట్ సైడ్. ఇప్పుడు మీరు స్ప్రింగ్ కనుక ప్రెస్ చేసి వదిలితే ఏమవుతుంది, లెఫ్ట్ సైడ్ టైట్ గా ఉంటుంది కాబట్టి రైట్ సైడ్ వింగ్ ఒకటే మూవ్ అవ్వగలుగుతుంది. బట్ మనం వీడియో చూసాం చూడండి, రెండు ఫింగర్స్ మధ్యలో పెట్టుకుని స్ప్రింగ్ పట్టుకున్నాం కదా, ఎప్పుడైతే ఫింగర్స్ వదిలేసినాం ఏమవుతుంది, లెఫ్ట్ సైడ్ మూవ్ అవుతుంది, రైట్ సైడ్ మూవ్ అవుతుంది. దేర్ యు ఆర్ హ్యావింగ్ డిస్ప్లేస్మెంట్ బోత్ సైడ్స్. ఇస్ ఇట్ ఓకే? ఆ డిఫరెన్స్ అర్థమైందా? ఇన్ దిస్ కేస్ the spring is tightly fixed at one end, other side it is free. But in our problem, if you see here, in this particular case, if you observe, 1 minute. If you observe here, it is tied to both. That means the spring can move. It can it can give some force. Is it okay? So here that particular effect is taken as K2 into y1 minus y2, this displacement. Now let us write this D'Alembert's principle. What it says, take some forces in one direction, like D'Alembert principle says that the forces acting on a body and the forces resisting the motion of that particular body will be equal. That means f of t will be equal to, what are all resisting here? F of t, it will be equal to fx1, fm1, fk1, fb and fk2. That's what the equation what we got here. F of t is acting. What is opposing? m1 d square y1 by dt square, because of the mass. Because of the damping or friction, here b into dy by dt. Because of the displacement of the first spring, this spring K1, just it is K1 into Y1. Because of the second spring, is spring K1, K2, M1 మీద some force create చేస్తాయి. అందుకని K2 into Y1 minus Y2. Same thing if you write for this particular next one, that is your M2. M2 మీద force ఏం లేదు, only spring ఒకటే ఉంది. అది ఎలా ఉంటుంది, but it is having its own mass. So both will be opposing the motion. That's why FM2, FK2. Now let us write the equation for FM2. M2 into d square y2. What is y2? Displacement. What is FK2? Displacement on M2. So these two equal. Is there any force that is acting? No. Only these forces are opposing forces, and you will be getting this equation. If you write down these two equations combined together, this will be the mathematical representation of my system. Amma, this session may be closed. Please rejoin. Okay, I'm ending the session.